Hello everyone, in this video I'm going to be finding the inverse function of this function, and we're going to be graphing the functions and find the domains and the ranges of each of the functions. Okay, so given that this function is a one-to-one function, we are asked to find its inverse, which is also a function. So the first thing that you're going to do is change f of x to y. Y equals x squared plus 4. And then interchange x and y. So we're going to write x equals y squared plus 4. And then we're going to solve for y. And of course, since we interchange x and y here, we have to do it here as well. So now y is greater to 0. And then we're going to solve for y. So we have x minus 4 equals y squared. So y squared equals x minus 4. I like to write, I want to write the y squared on this side and x minus 4 on this side. And then I'm going to finish solving for y. So I'll take the square root of both sides. So you get y equals, now I want y greater than 0. So we get the square root of x minus 4, not the negative of the square root of x minus 4. So just the positive square root of x minus 4. And then last step is we will write y and function notation as inverse of x. Okay, so, and we have y is greater than 0. So again, to find the inverse function, you write f of x as y. You interchange, from here to here, you interchange x's and y's. And we did that here too with the restriction. And then we solve for y. And then we replace the y with function notation. Okay, so now the next thing to do is to graph these functions. So we're going to take one at a time. So we have f of x equals x squared plus 4, or x squared when equal to 0. Okay, so I'm going to graph these functions using transformations. So I start out with the parent function, and I'm going to choose just some key points, some small numbers. These are what they choose in the book. They might choose -2 and 2 as well. But just small, easy numbers to work with is what you want to choose. Ones choose -1, 2, and 0 usually work pretty well. So then we plug these x into here. So we get 1, 0, and 1. But we want this function. Okay, so from this x to this x, nothing changed, right? There isn't any new arithmetic. We didn't add anything, subtract anything, multiply anything to x. Nothing changed. But from this y to this y, we added a 4. So we actually took this graph and did a vertical shift up 4 units. So the x's will stay the same, right? Nothing happened to the x's. They didn't change. But the y values, all these y values, we're going to add 4. So you get 1 plus 4 is 5, 0 plus 4 is 4, and 1 plus 4 is 5. Okay, and this is what we will be graphing. Now, not exactly. So we want our restriction is greater than or equal to 0. And I'll explain why that is in a little bit. So we won't be looking at this point. But I put that on there anyways because I want to show y'all something. Okay. So then we need to look at the graph of this function. Okay, so I'm going to choose, well, square root of x is the parent function, starting function. And I'm going to choose 0, 1, and 4 as x values for this function, just small, easy numbers to work with. So square root of 0, if I put 0 in here, square root of 0 is 0. If I put 1 in here, square root of 1 is 1. And if I put input the 4, square root of 4 is 2. And what I want to graph is this function. So I look at my x's. So from here to here, what changed? It looks like you subtract 4, but you actually do the opposite. You're going to add 4. You always do the opposite operations to the x's. And then how about the y? So from here to here, there's no number written here or here. So nothing was done to the y. The y didn't change. All we did was a horizontal shift right 4 units. So my y values stay the same, but my x values, I'm going to add 4. So 0 plus 4 is 4, 1 plus 4 is 5, and 4 plus 4 is 8. And so this is what we want here. Let's take a look at that. It's here. So now I want x values greater than or equal to 0. So I'm going to leave out negative 1, 5, because that's less than 0. And we'll come back to that in a minute still. So I have 0, 4, and 1, 5 are what I want. So 0, 1, 2, 3, 4, and 1, 5. So 1, 5. And so this is what I have. Now, the point negative 1, 5 would have been here, and it would have had this parabola, right? It's a parabolic shape. But the thing is, without the restriction, the function is not a one-to-one function. So its inverse wouldn't be a function. So we had to restrict it. We had to restrict it to x greater than or equal to 0. And that's why it was given to us like that, so that its inverse is also a function. So that's the story behind the restriction. And then now we're going to graph these numbers. So we have 4, 0, 5, 1, and 8, 2. And then the shape of the square root graph goes like this. And if you look at the two graphs, they're a reflection about the line y equals x. So again, this is the graph of f of x equals x squared plus 4, x squared equal to 0. And this is the graph of f inverse of x equals the square root of x minus 4. And we have y is greater than or equal to 0 here. So let's look at the domain and range of f and the domain and range of f inverse. So if we look at f, now it's given to us. That was given to us. The domain of f was 0 to infinity, including 0. And we can see that. So we read left to right, it's x is greater than or equal to 0, right? All the x values are greater than or equal to 0. And the range is from, we read bottom to top. So 4 up. So our lowest y value is 4. We're reading y values to infinity. And we include 4. So we bottom to top, y values, right? 4 to infinity, including 4. And then if you look at the domain of f inverse, so it's just the inside, say greater than or equal to 0, and you solve for x. So x is greater than or equal to 4. So from 4 to infinity. And we can see that from the graph. 4 starts at 4 and it keeps going to the right forever, right? So left to right, it's from 4 to infinity, including the 4. In the range, well, it says greater than or equal to 0. The y's have to be greater than or equal to 0. So we would write that in interval notation. So 0 to 4. I'm sorry, 0 to infinity. And with functions that are inverses of each other, the domain of f and the range of f inverse are equal. And the domain of f inverse and the range of f are equal. So these two are the same, and these two are the same when the functions are inverses of each other. And so all you really need to do is just find the domain of each one, and then just copy that answer here, and copy this answer here, because they're equal to each other. And so yeah, if you had the domain, just look at the domain of f, well, that's given. And then so we could just copy that here. The domain of f inverse, well, we just set the inside greater than or equal to 0, so we get this, and then just copy that here. So inverse functions undo each other. And that comes in handy when you start solving certain equations. For example, exponential equations. So if we look at the points, just look at these points real quick. This is the last thing I want to leave you out with. So if I look at this point 0, 4, and this point 1, 5, let's see, this point 4, 0, and this point 5, 1. So what we have is, and this should kind of be more over here. So this point is 1, 5. Lines up more with 1. So we just draw like this. So this is to here. Okay, so let's look at 0, 4. 0 will be the input of f. So I have f of 0, that's 0 squared plus 4. My output will be 4. Then when I take this output of f and make it the input of f inverse, then it becomes the output is 0. So f inverse undoes whatever f did to it. So f took 0 and it squared it, added to 4, and it got out of 4. And then we put that result, the output becomes the input of f. It does something to it, which undoes what f did, and the output is 0. So the output is the same as our input because they undo each other. So let's look at 1, 5. So 1 is the input of f. It squares it, adds 4 to it, and we get out 5. That 5 is the output of f that is now the input of f inverse of x, of f inverse. And it does something to it, subtracts 4 and takes the square root, and the output is 1. So f inverse undid whatever f did to 1. It undid that, and now the output is a 1. So the output is what the input was. It's the original input. And it works the other way too. So if we take 4 and put it into f, we get out a 0, right? 4 minus 4 is 0, square root of 0 is 0. We get out a 0. Then that output becomes the input of f of x. And so we get out, the output's 4. So the input was 4, and the output is 4. So f undid whatever f inverse did. And so the input and the output are the same. They undo each other. That's what makes them useful. And it'll be useful when we solve equations. So that is all I had to say about that. That's all I have for this video. I hope that helped. So again, we had this one-to-one function, and we were asked to find the inverse function, because if you have a one-to-one function, we know that its inverse will be a function. So we found that, and we took our steps to do that. And so we got this, and then we put both of these, we graphed both of these using transformations. We found both graphs using transformations. And then we put both of these, we drew both of these on our graphing paper, and we found the domain and ranges of each. And we saw how, by the points, how they reflect about the y equals x, the line y equals x, and how they undo each other. Okay, guys, that is all I have for now. Again, I hope that helped. Please feel free to check out my other videos, and I will talk to you on the next video. Thanks, guys. Bye.